Hey, this is Tony from Adafruit, and in this video I'm going to look at an interesting tool for MicroPython called mpy-utils, and this is a set of little functions and programs to help copy files to a MicroPython board. So you can push like Python source code, a library, for example, over to a board, similar to a tool that I created called Ampy. But there's a really neat feature in this tool that uses something called a fuse file system. That's a user space file system, so that you can actually make your MicroPython board look like a drive connected to your computer. And we'll try it out and play around with it. Unfortunately, that fuse file system mode does not work on Windows. I tried, I gave it a valiant effort to get it working. This is my ThinkPad over here that runs Windows. I tried in Cygwin and a whole bunch of other crazy things, and it's maybe possible if you rewrite the tool, but we'll look more at it. So for now, that fun fuse file system mode only works on Mac OS X and Linux, and we'll look at how to do it on Mac OS X. On Linux, it's even easier because Fuse is built in. There's one thing to install on Mac OS X. But even if you're on Windows, it's still an interesting tool because you can still copy files onto your MicroPython board. So you can send a file or directory onto the board, just like you can use a tool like Ampy to do that also. But it's nice to see other tools like this, and especially as the MicroPython ecosystem starts to grow, I'm sure we'll see other tools that are like this in the future. So let's just kind of dive in. This will probably be a little bit of a quick video, not any coding or anything in this video. I'm just going to run through how to use this tool, just because it's been a busy week and haven't had a chance to do a lot of coding stuff. So let's go into the main view and see what we're working with here. Okay, so the tool that I mentioned is this mpy-utils project. So MicroPython utilities, created by this person here, I think Nick Zoik, I'm not exactly sure his name. So I saw a talk that I think he did where he mentioned this tool, and so it looked pretty cool and I wanted to check it out. And so like it mentions, there are three little tools that are a part of this set of tools. They're all written in Python, and it's all pretty straightforward. If you want to look at the source code, it's all in here on GitHub. There's a tool called mpy-upload that will take a file from your computer and push it onto your MicroPython board using the serial REPL. So up in the upper right-hand corner right here, I have this is an ESP8266, the Feather ESP8266. It's running MicroPython right now. So you can push a file from your computer onto this board, like a main.py file if you want to run some Python code, whatever you want to do, you can copy it over. There's an mpy-sync tool that will copy a directory from your computer and all of the files inside of it onto your MicroPython board. So this is good if you're installing like a module where you have a folder with an init.py and then a bunch of Python files or MPY files or whatever inside of there, like a module you might have downloaded from Adafruit's GitHub repository. You can copy that over onto your board using the mpy-sync tool. And then the last one is the really cool thing that we're going to look at, this mpy-fuse, that will do this magic thing that actually makes this Python file system, MicroPython file system, look like a drive on my computer so that I can open it in the Mac OS X Explorer. I can drag and drop files onto it. I can use all of my standard command line tools, if I want to recursively copy files, if I want to grep through all of the source code, I can just go into that directory and do that, which is really cool and a really powerful thing. But again, it doesn't work on Windows right now, but I'll mention some hints. You might be able to get it working if you're able to kind of hack the code a little bit. It's just unfortunate that Windows does not support this fuse file system, at least right now. They're making a lot of headway into getting Linux support into Windows, so maybe in Windows 10 with the Linux subsystem in the future it might work, although I looked into that and it doesn't work right now. It doesn't have Fuse support, so bug Microsoft, tell them to add Fuse support. If they really care about Linux and Windows, that's a pretty critical thing to make stuff work. So okay, anyways, let's dive in then on how to install this. So, and again, you can use this on Mac, Windows, and Linux. Both the upload and the sync commands are fine. It's only that fuse command that works only on Linux and Mac OS X right now. But to install this, the easiest way is using pip. So make sure you install Python. I think this works with Python 3. I have not tried it, so let's actually try it for fun. But you can use pip to install it. So if you want to install it on Python 2, usually you have pip, or there's sometimes a pip2 command installed if you have homebrew installed. and you're using Python through Homebrew, and you probably know what you're doing, so you probably know that you need to use pip too. If you're not sure, try pip, and you should hopefully see that you get this command back. If you don't see this, then you probably don't have Python installed, so go to python.org and install Python. Anyways, so you want to do, on Mac, since I'm using Apple's Python, which is installed in the system folder, I need to run pip with sudo. If you're using Homebrew Python, you shouldn't use sudo. This is just a really confusing thing that is unfortunately, I don't know, I wish the Python world would make this a little bit easier, at least on Mac OS X. So if you're ever unsure, sudo will usually always work, but there are some cases where you're not supposed to use sudo. So try it without sudo. For example, I can try pip install mpy-utils, and this is probably going to fail. Oh, well, it actually tells me I already have it installed, but I can actually do this force command that will force reinstalling it, and this is maybe not. I forget what the syntax is. Maybe, I think I have to put the force before here. Let's see. This is, we're learning how to use pip in the beginning of this video, which pip has always kind of struck me as a very prickly command to use. At least it's not very friendly. It doesn't seem to do the right thing. Like, okay, well now I'm just mad at pip, so I want to see, how do I force you to install this package again? There's some kind of esoteric parameter that you need to add to it. You would think that the default behavior would just be, here it is. Force reinstall is what I need to use. Not force reinstall. So I guess the pip developers want you to be a little bit more verbose about this. So mpy force reinstall, mpy-utils. Boy, it really doesn't want to reinstall this thing. Geez, let's see. Is there some other magic command that I'm missing here? Let's see. Okay, here we go. I think I need force reinstall and ignore install. Let's try this. So you probably don't have to do this when you're installing this. I'm just doing this because I'm actually a little bit mad and I want to see this thing fail so that I can kind of prove a point here. Let's see if this works. Okay, there we go. There we go. Okay, so if you try the simple pip install mpy-utils on Mac and it fails with this permission denied error, what's happening here is, by default, Python is using the Python that Apple included in your OS X installation. So when you run Python, you can actually see this GCC 4.2 compatible Apple LLVM. This means that you're using the system version of Python, which, the way it's configured, you have to pip install using sudo. So you just want to run your sudo pip install mpy-utils command again with the sudo command like this, and then it'll work. Now, the reason I said to try this without running sudo first and see if you get this permission denied error is because if you've installed Homebrew and you've installed Python using Homebrew, then that replaces your Apple Python, and now your Python is from Homebrew, and the way Homebrew installs Python is that it puts it into your user directory, which does not require sudo, and actually you shouldn't use sudo to pip install stuff because it'll install it as a root user, which might cause you problems down the road. So basically try pip install. If that fails with the permission denied error, then rerun it with sudo. On Linux, again, there's this murky area. On Ubuntu, you need to pip install using sudo in general. On like Arch and other distributions, you might not need to use sudo. So again, try it without sudo. If it tells you that you get a permission denied error, use sudo. On Windows, you don't need to use sudo because I believe your normal user has the privileges to write to where Python is installed. So on Windows, it's easier, actually. I wish it was this easy on every platform, though. This is just a nitpick about Python, that they sure don't make it easier for beginners to figure this stuff out. And the only reason I know this is because I've done this a million times and figured out, banged my head against the wall and realized what's wrong. So anyways, just to summarize, this is the command you should try to run: pip install mpy-utils. If that fails, throw a sudo in front of it and it should work. And then just to show what the install looks like, I'm going to do, let's go back and let's do this force reinstall, ignore installed, and then I'm going to throw a sudo in front of this just to show this is what you'll see when you run this command and it works. Oh, and it wants my password, of course, because I'm using sudo. And you can see it complains that it's, pip is not owned by the current directory, blah, blah, blah. Ignore that. Again, it's just the pain of the way Python and pip work on Apple Python. Anyways, so the one thing that you want to make sure that you see is that, installed collected packages and successfully installed these packages. If you see an error or something, it didn't work. So you need to go back, and there's probably like a sudo or some kind of other issue. Anyways, that's all you need to do. Unfortunately, it's a little more complex, but it really is as simple as just running a pip install. And then just to check that it's there, try mpy-utils --help. And so you should hopefully see some usage information printed like this. If you see an error or something, then it probably didn't install. So you need to go back and double check that it reinstalled. That it installed correctly. Okay, so like I mentioned, there are 3 tools in here. There's mpy-upload, mpy-sync, and mpy-fuse. My mouse sometimes, again, this is when it gets dust on here, it doesn't really track very well, unfortunately. Anyways, so mpy-upload, this is the tool that will push a file from your computer onto the MicroPython board. So I'll demonstrate that real quickly. On my computer here, let's just make a file called, how about hello.txt, and then just for fun, let's put some stuff inside of there, hello world, and I'll write that out. So now if I look in my directory, see I have a file called hello.txt that has hello world in it. And then to push this onto my MicroPython board, so I've connected my board to my computer, and just to be sure it's connected, I'll connect to the serial REPL. So if I open the serial REPL for this board, it's the Scilabs USB to UART 115200 baud. And so I can see if I press Control D and then Control B, then I get my Python prompt. This is because when I was previously using the tool, it left the board in the raw REPL mode. So if you ever open up the REPL and you don't get anything, you're pressing enter and you're trying to see, you're pressing like Control C and nothing's happening, try pressing Control D, D as in dog. That will do a soft reboot. And then when it reboots, you might see a message that says something like in raw REPL, press Control B, B as in boy, to exit it. Then press Control B and that will exit this raw REPL mode. So we'll probably see an example of this in a moment. After I upload a file, it's going to leave it in this raw REPL mode. But just an FYI that sometimes your board is in a state where it's expecting a tool to talk to it, not your kind of interactive terminal. And so it goes into this mode where it won't show any output because your tools don't care about that output. But as a human, I want to see the output. I want to see the prompt. I want to see what I type. So that's what that raw REPL mode is. And Control B will get you out of that mode. And then Control D will reset the board so that it's back in a blank kind of, it'll reboot the board effectively so that like if any program was running, it'll stop running it, stuff like that. Okay, so just to show that that file, oh wait, no, I haven't uploaded the file yet. So I just wanted to show that my board is connected and that it's out of REPL and we're ready to go. So I'm going to exit out of my REPL command. Now to use that upload tool, it's pretty easy. So I'm going to run the mpy-upload command. You have to give it 2 parameters. You have to give it a port parameter, which points at the serial port that's connected to your board. In this case, it's this TTY Scilabs USB to UART. And then you also have to give a baud parameter, so 115200 baud, to connect to the serial REPL. And then you just give it a list of files that you want to upload. So like that hello.txt, you can list other files in here. You know, if I had other like .py files or whatever, I can put them after this. But I don't believe that this can send directories. We'll see in a second. There's a separate tool to send directories. So when I run this, it will upload the file. You don't really see any output as far as I can tell, so hopefully it worked. I think if it fails, it hopefully throws an error message. I haven't seen it fail yet. And now let's connect to my board. And now you'll see this weird state, like I'm pressing enter and nothing's happening. So again, this is in the raw REPL mode. So what you want to do is press Control B as in boy, or you can press Control D as in dog to reset the board. I'll do Control D. I'll show you what happens when you reset the board. So I do Control D. I get this OK prompt. That's just telling me that it reset and it's in the raw REPL mode. So now I'm going to press Control B as in boy. And now I'm back to my normal Python prompt. So again, I was just kind of demonstrating what happens there. But anyways, let's just check that that file is there. So import the OS module and then os.listdir, oops, should hopefully show, and I've got a bunch of other files on this board, but here is that hello.txt file, so that's cool, the file is there. And then just to show that we can really open it, let's open that file and let's point it at hello.txt, open it for reading, and then let's just read the entire file back. So hey, there it is, hello world. So that's the contents of our file. So cool, so that's how you send a single file to the board. There are other tools that do this too, like my mpy tool that I've shown before and I have a guide on. I'll put a link to that guide in the description. And by the way, I'll put links to all of these tools in the description below, like the GitHub repository for this mpy-utils and things like that. So you can look and get a link to that easily when this is up on YouTube. But anyways, yeah, so I have a tool called Ampy that can also send files to the board. All of these tools work the same way. They connect to the serial REPL and they send the file to the REPL, and they actually run the Python code to open the file, create it, send the data into it, which seems a little weird, but you know, it's simple and it works. So, you know, hey, don't knock it till you try it, I guess. Okay, so let's try out the next part of this set of tools. There's the mpy-sync command, and so this will copy a directory from your computer onto your MicroPython board. Now there's one little quirk about it. I don't know if this is by design or if it's just a bug or something. It doesn't seem to create the directory on your MicroPython board, so that directory needs to exist on your board. So just to show you how this works, in the directory here on my computer, I have a test directory, and inside of there I have two files, this bar.txt and foo.txt. So you can see there are two files inside of there, and that's just inside of this test directory. So I want to copy this test directory and both of the files, or everything inside of there, onto my MicroPython board. Before I can do this though, I need to actually connect to my MicroPython board and create that test directory. So I'm going to connect to my MicroPython board. I'm at the REPL. I'm going to import the OS module, and I'm going to call os.makedir test. So that's going to make a directory called test on my MicroPython board, and I can actually see that if I list all the directories. You can see, or if I list all the files or things under the root, there's my test folder. Okay, so now that I've done that, I can use the mpy-sync tool. Now, it says sync, but as far as I know, this is just a one-way sync from your computer to the MicroPython board. I don't believe that this goes from the board back to your computer. So just an FYI, it's more of like a push. I don't know if there's a special name for that, but it's copying a directory effectively. So this is good for like copying a library, which is or a module, which is a folder with a bunch of files in it. Anyways, again, it needs to take the port, so the serial port for your device, and then the baud rate, so 115200, and then the directory I want to copy. So the test directory is what I want to do. And again, make sure you've created that test directory on your MicroPython board before you use this. It won't error out, it just won't work. It'll say that it worked and the files won't be there. So just an FYI thing that I noticed with it. So we'll do this, and it takes it a second. So you can see it noticed that there were some files there and it copied them over. So let's connect back to the REPL on my board again. And again, I have to do the Control B. I guess I can just press Control B. I don't even have to do Control D as you saw before. It doesn't hurt if I do Control D right now. That just does a soft reboot. So again, if you're ever in a weird state, try Control D, Control B, Control C. That's just gonna stop anything, reset the board, you know, give all those chances to get it back into a good state. And let's import the OS module. So os.lister, so we still have the test directory, that's good. And then if I listdir the test directory, hey, look at that, we see bar.txt and foo.txt inside of that test directory. So that means that we copied those files from my computer onto the board. So it worked, so that's cool. That's pretty handy to have a file or directory copy tool like that that'll work with your boards. And again, also the Ampy tool, in the latest version, I've added a recursive put operation that does the same thing. You point it at a directory on your computer and it will copy it onto your board, and all of the files inside of there it will copy. You don't need to pre-create the directory with the ampy put command though, so it might be a little bit easier to use that. Okay, so let's look at the last thing, maybe the star of the show, the mpy-fuse command. So this is actually really cool, and why I looked at this set of tools. So there's a little bit of setup that you might need to do for this. So if you're on Linux, everything should just work, fingers crossed, because this thing called Fuse, it's the file system in user space, or I can't remember exactly what it means, is built into all of the recent Linux kernels. And recent as of, I'm sure, like 5-10 years ago. So it's been around for quite a while. So it should just work if you're on things like Ubuntu or Arch or whatever the latest Linux versions are. But on OS 10, you need to install something. So you need to go and install this OS 10 Fuse package. So this is what you want, the latest stable release, the Fuse for Mac OS package right here. So go and install this, and I'll put a link in the description below when this goes up on YouTube. And then after you install this, then you can use this mpy-fuse command on Mac. And again, on Windows, unfortunately, I really tried. I had my Windows machine here. I spent a good couple hours fighting Cygwin and all kinds of other things to get this thing to work, and it's a no-go right now. So the way what this tool does is it uses this thing called FusePy, which is a wrapper around the Fuse file system, it's just a Python interface to it. Now this would work on Windows if FusePy worked with this thing called Dokken, which is not the I think 80s hair metal band, but no, this is a Fuse wrapper for Windows. But FusePy is not made to work with Dokken, and maybe there are some simple modifications that make it work. But once I started going down the rabbit hole of having to modify the FusePy code, just not worth it. There's also another tool that I saw, a more recent one called, I think, WinFSP, I believe it's called. WinFSP. This is a newer thing. Oops, let me go back here. Let's go to the home page for this. This thing actually looks really neat. This is, again, a Fuse implementation for Windows. But again, it only works in Cygwin, and I still couldn't get it to work. I tried all kinds of things. Cygwin is this Unix wrapper for Windows. There's just a lot of pain because you need to use the Python version in Cygwin and not the Python version in Windows. And then you also need to use the pip version in Cygwin, but Cygwin doesn't install pip, so I'm not going to bore you with all the details, but just trust me, I know what I'm doing, and I couldn't get this to work. So, it's just, if you're on Windows, unfortunately, this is not going to work right now. Not to say that it will never work, it's just someone's going to need to rewrite this tool to use a Windows-compatible Fuse layer, or Microsoft needs to implement support for Fuse. So maybe that's probably the ultimate nice fix, because hey, they're adding Linux support, so why not go all the way, guys, and add Fuse support. There's a bug also that they have open on their kind of user voice, which has not gotten any traction, unfortunately. Anyways, long story short, let's do this on Mac OS 10. So like I said, I've installed this Mac OS 10 Fuse driver, so that's all ready to go. And so now I want to use the mpy-fuse command, and so I'll give you the help info for this. So before you use this, you have to create a mount point, which is just a folder, and that's going to be where this is going to be located, because it's going to show up not as a drive, but kind of like a folder that looks like a drive. I'll show you what it looks like in the Mac File Explorer in a moment, but basically you need to create a folder somewhere that's going to be empty, and then it's going to turn that folder into like a virtual drive that looks like all of the files on your MicroPython board. So that's kind of what this mount point positional argument is that it wants. So I'm in a directory here, and I have this directory I created called board, LSL. We'll just show you. I have this board directory, but if I want, I can delete that, and I'll just show you. And if you don't have a directory, make dir, make a board directory. And then make sure it's empty. I'm pretty sure, I don't think it's going to delete everything in there, but I don't know for sure. So make it an empty directory just to be sure. Don't point this at your home directory, for example, or something like that. Okay, so then you want to run mpy-fuse and point it at the serial port again, the Scilab's device in my case. Use the baud rate for your board, and then the mount point, I want to point at that board directory that I created. So I'm going to run that, and it's not going to do anything. At least you won't see any output unless you see like an error, in which case like something went wrong and it didn't install correctly probably. or you didn't have maybe this Mac OS X Fuse package installed, so make sure that that's installed. Anyways, once it's running, I'm going to open up Explorer, and let me go to my download directory right here real fast. Let me just make sure I get to the right spot real fast. Okay, so this is the directory that I'm in with my terminal, and you can see there's that hello text file in the test folder. But notice this, so I don't see that board folder anymore. It's turned it into this OS X Fuse Volume 0 Python. So if I double click this is kind of cool. Notice this is actually showing me all of the files on this MicroPython board. And you can see I have a bunch of stuff installed. This was a board I was using to demonstrate some stuff like this, the LED matrix. I had a little example running on here. But this is pretty cool, and I can open up these files and start editing them. So for example, like here's this hello.txt file. So I can open this up, and this is just the Mac OS X text editor, and I could write to this, written from text edit, and I can save this file, and that works. That's all goodness. So when I close this, it's going to write it back. Oh, okay. This is a dumb thing. So what it's complaining about here, Mac OS X, yeah, okay, discard this. So the text editor built into Mac OS X is a little bit fancier than most text editors. It's trying to save previous versions of this file, but the Fuse file system has no idea because those older versions are stored in a special extended part of the file system, and I don't believe Fuse supports that. Long story short, use a different text editor. You probably want to use something like maybe the Atom text editor. So if I open up Atom, and then if I open up that folder in there, let's go into my downloads and MPY. And now if I open this up, now I should hopefully be able to just edit this thing directly from my text editor. So yeah, like here's that hello.txt file. And let's see, written from Atom. And then now hopefully, I haven't tried this, let's save this, and hopefully this works. So I click save, and okay, yeah, it looks like it saved it on the board, like at least Adam told me that it saved. So if you run into that error and you're using the basic text editor in OS X, don't use the basic text editor in OS X because it tries to outsmart you, unfortunately. So use a simple text editor, well, maybe not a simple one, but use one that doesn't try to store those old versions of files. Maybe there's a way to turn that off in OS X, but I'm not sure. But anyways, again, this is really cool. Like I can see all of my source files. Here's the boot.py file on here. I can dig into some of these subfolders and see there's like these MPY files, which are binary files, so I'm not gonna be able to read those. But everything's in here. Here's that test directory and stuff like that. So that's pretty cool. And I can open up a new terminal window if I want, and I can go into that board directory, and I can run, here's my ls command, and that's listing all the files on my MicroPython board. So again, it's mounted as if it's like a directory on my computer, and I can use all the tools that I want. If I want to search for, let's look for a string, let's look for hello in all of the files on my MicroPython board. So this is kind of the grep syntax to do that. And so this is actually going to go and open every file and start searching through it. Now it's not going to be fast because, again, it's got to send all those files over that serial connection, which is 11.5.200 baud. I think it has to copy them locally into a cached folder. So, you're not going to find things very quickly. And, oh, interesting, it didn't find upper or lowercase hello. Was it uppercase hello that I had in here? Let's try this again and see. There we go. So this is kind of cool. You can see, like, I just grepped all the files on my MicroPython board. Because it shows up as a file system, I can use all of the tools on my Mac right here to do this. So it found that in a couple files here. So that's pretty cool. And then again, so this will only work while this tool is running like this. When I stop running this tool, that little file system goes away, and it's not going to automatically be mounted every time my computer boots up. You'd probably want to create some kind of magic like startup script or something that does that. But that's not so bad because, you plug in your board, run this command to get your file system going, and then open up your editor and start partying on your code right here. And then, as you save files locally, they should copy over and work and be available on your board. So that's pretty cool and something that I think is neat and worth checking out with this tool. So it's the mpy-utils package. Again, it's got 3 different tools right now. It looks like there's a simple file copy, a folder copy, and then this fuse tool. And the fuse tool, again, only works on Linux and Mac OS 10, but I'm hopeful that someone can get it working on Windows at some point in the future, because there's no reason why it couldn't work on Windows. It's just the Windows Fuse implementations are, not that they're bad, it's just that Windows is not conducive to supporting this kind of user space file system. So everyone has to kind of do things their own way, and then you have to code against that. And so it's not like a nice standard yet, unfortunately. So anyways, that's it. I'm going to wrap it up. If folks have questions, throw them in the chat. Like I said, this is a little bit of a quick video, but really neat tool that I wanted to point out and show some cool things, and just showing it a new way to edit files on a MicroPython board, and how to set up a nice workflow of using an editor on your computer locally to edit files on your MicroPython board. So that's pretty cool and pretty powerful. Okay, so I don't see any questions, so we'll wrap it up. I'll jump back to the main shot. So anyways, thanks a lot. It's Tony from Adafruit. Check out youtube.com/Adafruit. You'll see this video and all kinds of other fun project videos. Check out twitch.tv/Adafruit, and you can watch me stream these things live. I like to do a live stream every Friday. I've been on a roll for quite a while, doing lots of MicroPython and CircuitPython related things. So be sure to stay tuned, and I'm sure you'll see a lot more CircuitPython and MicroPython content in the future. If you like this stuff, then click the like or the comment or the subscribe button. Let us know that this is good stuff, and we'll keep doing things like this. So until next time, thanks a lot for watching. This is Tony from Adafruit. I'll see you later. Bye.